Today's science seminar topic is quantum is begins, its potential and its challenges. First thing I want to talk about that what is quantum physics? Quantum physics is a branch of science which shows matter and energy at a fundamental level of atomic and subatomic level. Second thing, why do we use quantum computers instead of classical computers? Before the quantum computers, classical computers have many potential to do the complex problems, but when the quantum computer take place, the quantum computer take the future. It can solve many complex problems, but in the classical computer, it works in a binary or bit system where 0 and 1 work separately. But in quantum computer, there is qubits or quantum bits where 0 and 1 works simultaneously. There can be 0 and 1 at the same time. This is quantum superposition where any object at the same time. Next phenomena of quantum physics is quantum entanglement. In quantum entanglement, the qubits are interconnected with each other no matter how far they are. Then we have building the future, the three pillars. First, we have quantum computing. Quantum computing uses qubits to perform many complex problems for our daily real life scenarios. Second thing is quantum communication. It creates information and give it to the quantum encryption where any eavesdropping will easily detectable. Third thing is quantum sensing. It uses quantum properties to measure anything precisely. That's why it uses in the fields like navigation to medical diagnostics. Then we have next topic that is called application of quantum tech. There are many ways where we use our quantum computers, like it stimulates molecular interaction to make new drugs and modern and advanced materials as well. Second thing is uses in finance. It can solve many complex optimization to save our money from the high frequency trading, risk modeling and fraud detection. Next thing is cyber security. It is very important. Our classical computers are not able to fight from the cyber security. Our quantum computer is very powerful with information from the future attacks. It can predict the future. When you input a thing in the quantum computer, it can give you different scenarios of an object, of a thing you had inputted. The output will be very different from your input. You can get very different scenarios, very different situation. When I have a medicine, I have to make a medicine. I need so many properties to make it. I don't know how much I put the thing that the medicine will make. But in the quantum computer, if I input the particular value, it will give me different scenarios and different particular objects which I can do, and I can choose it from the most appropriate. Third thing is AI and machine learning. It speeds up algorithms for vast data sets. The advanced quantum computer will advance our AI. Our next topic is facing reality, technical hurdles. Quantum decoherence and tether. These quantum computers are very fragile, and there are qubits which working on them, and they are very fragile. Any small interruption, noise, voice and vibration can make an error in the qubits, which doesn't give us the particular output we had inputted. Second thing is hardware and scalability. Requires specialized and expensive hardware such as diluted refrigerator. What is diluted refrigerator? When the quantum computer is working, it generates excess heat. And when the computer is heated, the qubits don't work properly. That's why we need diluted refrigerator where helium 3 and 4 liquid gases are engaged to cool down the qubits. Next thing is its cost accessibility. High cost and low research, government, private factories and labs, they are shortage of it. That's why the ability of quantum computers to break existing encryption poses a serious risk to current civilization. We knew that the quantum computer uses qubits, which is way powerful than the classical computer supercomputer. The classical computer can be easily hacked by a quantum computer because it has a vast potential. Next thing is the talent gap. There is a very much shortage of experts in quantum physics, engineering. There are so many short number of scientists who knew about the quantum physics vastly. Next thing is the SS divide. Unequal SS could exacerbate global inequalities, creating a new quantum divide between the tech rich and tech poor. The next thing we are going to talk about is mapping the future, the road ahead body. Investment in research. If we are talking about quantum computers, we need a continuous running of money in the development of quantum theory and physics and computers. There is a education and workforce. There is a talent gap between people, we know that. But when the new generation of scientists and engineers are teachers with quantum physics, it will so much expensive. Then the next thing is international collaboration. We need international collaboration for quantum physics to develop more powerful quantum computers than ever, like Google, Meta, Facebook, etc. Then our next and our last topic is a new beginning, embracing the quantum era. The quantum age represents a fundamental shift in technology with vast potential and serious challenges. Responsible innovation, collaborative effort, and proactive policy are necessary to ensure quantum revolution benefits for all of the humanity. Include an inspiring and forward-looking quote about future of technology or science. Our 21st century will reshape and it gives our
the face of our belly.
no.
Yeah, kind of. Okay.
AI is very much powerful.
Yes.